Hello. Today we're going to look at 7-1, solving equations with variables on both sides of the equal sign. This is a review of work that you did back in chapter 3. Today you'll notice we have the equation 5x plus 4 equals 3x minus 2. First we need to move the variables from the right-hand side all to the left-hand side, and that requires us to subtract 3x from both sides. Remember, we're subtracting 3x because the original 3x is positive. Because you're such advanced math students, what happens to the 3x's on the right-hand side of the equal sign? They cancel each other out. On the left, the 5x minus the 3x leaves us with 2x. Bring down the plus 4 and the negative 2 on the other side. So now we're going to begin the process of moving the 4 from the left-hand side to the right-hand side by getting rid of it. Because it's plus 4, we're actually going to subtract 4 from both sides of the equation. What happens to the 4's on the left-hand side? They do cancel each other out. So now we're left with 2x equals negative 6. And that's a simple multiplication equation in which we divide both sides by 2. Again, the 2's on the left this time will cancel each other out. And we get x equals negative 3. When we do negative 6 divided by 2, we get negative 3. So that's a relatively normal size example of what you're going to see in your work tonight. And that's what it should look like. However, now I want to look at the same example, and I want to solve it two separate ways. One way is moving the variable over to the left-hand side like we've traditionally been working on. So we will subtract 3x from both sides. And the 3x's on the right-hand side cancel each other out. And 2x minus 3x is negative 1x plus 3 equals 0. Now we need to get the variable all by itself. So we'll drop the negative 1. So we'll have negative x plus 3 equals 0. Now we'll subtract 3 from both sides to get the x all by itself. And what happens to the 3's on the left-hand side? They cancel each other out. We get negative x equals negative 3. Now the trick that we talked about earlier this year, when we have a negative variable equaling something, was to simply take that negative sign and move it over into the answer. And since we move the negative from the left to the right, since 3 is negative to begin with, the negative cancels the negative out. So we're left with x equals positive 3. Now, remember, we're allowed to use this trick because you're really dividing both sides of the equation by negative 1, and that gets rid of the negative sign over by the x. And negative 3 divided by negative 1 is positive 3. Now, another way to do the exact same example is to look at it for a minute beforehand, before starting to solve it, and realize I have 2x's on the left-hand side of the equal sign and 3x's on the right-hand side of the equal sign. A lot of people don't like to work with negative variables, so in order to do that, why don't we move the 2x to the right-hand side of the equal sign and see what happens that way. So we're essentially going to solve the same equation from a different perspective, subtracting 2x from both sides. The 2x's on the left-hand side cancel each other out, and 3x minus 2x is simply x. And then we're left with the 3 on the other side. So in one step, now we have x equals 3. So you can see the two examples. One has a substantial amount more work than the other. And it's fine to do all the work. It's also fine to take the shortcut. But be aware that all equations won't solve this simply, this quickly every single time. You will have to do some work to show your work. And then finally, your homework is going to be on the book, page 332 to 333, problems 10 through 36 of the even-numbered problems.